Hi, this is a short introduction to confidential computing with SCONE. In SCONE, we provide what we call application-oriented security. So in this context, we assume we have a service provider. Let's call her Alice. So Alice is a service provider, and she operates an application. So she has some application, and these days this will be a cloud-native application consisting of multiple components. There might be a load balancer in the beginning. There might be some horizontal scaling with some services. So we have here two instances of services, and they might store their persistent state in a database. So we have a database here. And of course, these days the service provider wants to outsource the management of all the resources. So that means if we have now such services, we need an operating system or many operating systems. Let's only put one here on the slide. We might have a hypervisor, and that all runs on some hardware, and the hardware contains some CPU. And so in this case, we have also clients, and in this, let's change the color for the client. Let's make it green. And we have a client B, that's Bob, and Bob connects to the load balancer, and then his requests are forwarded to one of the services, and then they will go into the database. And I forgot to put here DB for database. Now, in the old days, Alice might have maintained or operated the operating system, the hypervisor, and the hardware herself. But these days, she will provide or she will outsource that to some cloud provider. And we have one more role, and that role is that of Mallory. Mallory is our adversary. And our adversary is in control of all the resources. So she can control the operating system, maybe by stealing some credential from some system administrator from the cloud. She might control the hypervisor. She might have a look at the hardware. She might even modify some of the hardware. But we assume that the CPU has some extension that is not under control of Mallory. So there is some trusted execution environment extension, and we assume that Mallory cannot control this part. And so with SCONE, we do in principle the following. We protect the application of Alice from accesses from Mallory, because Mallory might be interested in our data. So she might want to read the data that is in the database. She might want to read data that is in the main memory that's processed by this service. Alice wants to protect herself from such read accesses from Mallory. So she wants to enforce confidentiality of her data, plus the code, and of course of all the secrets that she might have in her service. And some secret might be the encryption key of her database. Mallory might be actually a little malicious, and she might not only want to read the database, but she also might want to modify that. For example, to give her extra money. Or she might want to modify the return or values or the results that the service sends to Bob. For example, to give Bob less money or the wrong results so that Bob takes wrong decisions. So therefore, Alice also wants to protect her service in the sense that no modification can be performed by Mallory, and so that the results are correct that she sends to Bob, and also that the state of the database is correct. So she wants to enforce integrity, both of the data and the code, and maybe also the secrets. Okay. And Alice, she wants to do that despite not being in control of the operating system, the hypervisor, or the hardware. So she has to protect herself against very powerful adversary. So adversary like Mallory that controls the operating system and can, in general, read the memory of her applications and also can access the database at any parts of the database, because access control to that database is actually controlled by the operating system, which is controlled by Mallory. So therefore, we need some extra protection. And here we assume that Bob communicates with the service of Alice via TLS. So we have some TLS protection. And for simplicity, we assume that in this screencast that the load balancer doesn't terminate TLS. So Bob can connect to the service. And in a later screencast, we will explain how Bob can actually make sure that this service runs inside of an enclave. But in this one, we assume that we have a TLS connection, and now we have to protect the byte stream that are transferred, communicate via the TLS connection against accesses by Mallory, so that this byte stream cannot be read or modified by Mallory. So therefore, we have to protect the endpoint. So the service has to be itself protected. And in this case, we want to have the service running in an enclave, so trusted part of the memory that is implemented by a part of the CPU, which is called a trusted execution environment. And so in this enclave, only the service can access this part, and this OS is not permitted to access this, nor is the hypervisor. So the operating system cannot access this part, the hypervisor cannot access this part, and therefore we can protect the service from accesses from Mallory. And the same is true now for the database. We can run the database, this database code in such an enclave, and we can transparently encrypt all the data that goes to disk. And in this way, we protect the database against accesses from Mallory. And we can also protect the communication between the service and the database. So that means with the help of SCONE, we can actually make sure that all the services that process confidential data are protected against read access, so the confidentiality is protected as well as the integrity. SCONE provides a so-called lift and shift approach. It provides the possibility to take existing binaries and execute them inside of enclaves. Moreover, it can ensure that all the services that are part of the application, like here we have two services, that they know each other, they can attest each other transparently, and also that the data that is stored in the file system is transparently encrypted and decrypted when it's read. And we control that in SCONE with the help of some policies. So the next screencast will show you how to actually take existing binaries, move them in enclaves, and ensure that the services know which other service belongs to the same application with the help of so-called SCONE sessions